All right, happy Friday, guys. Meteorologist Erika Lopez here in the KHOU Weather Center, here for your Friday Weather School lesson. And today's lesson, now it's an interesting topic. It's more of a geography lesson, which is needed in order to intertwine with meteorology. So today I'm going to be talking about time zones, universal coordinate time, and also what that means and why it's so important when you need to put together your forecast, because it's kind of the core basics, but it's also a little bit of a complicated subject. So I'm going to try to do my best to break it down. I know there's so many different ages and also so many folks tuning in that have different knowledge. So bear with me. I'm going to do my best to explain this. So what we're seeing here is a map of the world. Okay, a map of the globe. And we're seeing lines of longitude. This map is separated into 24 different sections. So we have 24 different lines of longitude here. And we're talking about, if we were to wrap this into a globe, it would be 360 degrees, right? Our globe, 360 degrees, which the globe rotates 360 degrees in 24 hours. Okay, so we're going to have to do some basic math here. 360 degrees, if we were to divide that by 24, I know, out of school, this is a meteorology lesson, math is later in the day, we're just going to do some basic math here. That is going to come out to 15 degrees. Okay, so what this means is that this map separated into 24 parts. A globe moves 15 degrees every hour. And once it completes that 360 degree day, it completes 24 hours. So that encompasses our entire day. So every section, if the globe were to go all the way around, it encompasses the entire day. Okay, so I'm going to give you guys some history here. Back in the mid-1800s, Greenwich, England. So here's the United Kingdom. I know this graphic is very, very tiny for you guys, but here's the UK. London's right there. Greenwich is just outside of the heart of London. And folks around Greenwich, Greenwich, England, they were the ones who invented the coordinated universal time. And what that is, it was very important in order for us to communicate across the globe time zones and timing of everything. And the reason why this is important is because all of our radar, satellite, all of our data, out of all of our computer models, they are in coordinated universal time. So let's talk about the United States time zones. First, I'm going to show you. So since it was officiated here, we're calling this 0. This is a very small number, but it says 0. And then this is what we call the prime meridian also. The prime meridian is the official center part of the world. All right, and that's what separates the Western Hemisphere from the Eastern Hemisphere. Anything east of Greenwich, England, and of the prime meridian of 0, anything east is the Eastern Hemisphere. Anything west is the Western Hemisphere. Us here in the United States, we live in the Western Hemisphere. Okay, and then let's pretend that it is noon right now, so 12 o'clock in Greenwich. Anything west is 1 hour earlier. So here, this is -1. So if it's noon in Greenwich, it's 11 a.m. right here in this time zone. It is 10 a.m. in this time zone. It would be 9 a.m. in this time zone, 8 a.m. in this time zone, 7 a.m. in this time zone, 6 a.m. in this time zone. And the reason why I'm stopping here at -6 is because this is where we are, Texas. All right, that's where the United States is. We are in the central time zone, and every time zone has their name. All right, so it's very important to also know the name of your time zone, where you live, especially if you're a meteorologist or wherever you're forecasting for, because that's going to help you translate into the exact timing of what computer models are saying of some type of severe weather that could be in your area. So I'm going to break down the different time zones here in the United States. We have the Eastern time zone, UTC, -5. All right, we have the Central time zone, UTC. UTC stands for Coordinated Universal Time. That's the global time stamp. And we are -6. So if you can just remember that, Central Time, us here in Texas, we are Central Time, and our time zone number is -6. There's also the Mountain Time, which is -7, and the further west you go, the further the negative number gets. We go down to Pacific, which is -8. We don't stop there because Alaska is west of Pacific time zone. They have their own time zone, -9, and the Hawaiian Islands are at -10. Okay? So it gets a little bit more complicated. If you're not already lost and not already kind of confused, it's okay. You can go back and rewatch this because we save them on YouTube, or also you can do a little Google search and kind of, I remember when I learned this in high school and in college, it took several lessons and several reads to really let it soak in my brain. And once it makes sense, it clicks, it makes sense. And then it makes your life a lot more easier in order for your forecasting to occur. Okay, so here's where it gets complicated. These numbers shifted, right? We're looking at the Central Time Zone, but it says -5. So this is showing daylight saving taken into effect. So us here in Texas, we observe daylight savings. And daylight saving begins in the beginning of March. It ends in November. And that is when in March, we spring our clocks forward 1 hour. So if we were to spring our clocks forward 1 hour, this is not daylight savings. And if I'm springing my clock forward 1 hour, we're jumping ahead 1 hour. Guess what? We're at -5 now. So we're sealing the Eastern time zone. So now we're at -5. So this is where it gets a little bit more complicated also, because as meteorologists, you have to remember when you're forecasting within daylight saving time from the beginning of March to November, our time zone number is actually -5 when we're translating coordinated universal time. All right. So just to make it even more complicated, check this out. So I grew up in Arizona, and it's actually really funny because I was so confused when I moved from Arizona to Texas because I didn't understand what was happening. Arizona is one out of the 2 states that does not observe daylight saving. Isn't that pretty interesting? So we never deal with this mess of changing our clocks. And it's because every area across the globe, as a matter of fact, it's all about the politics. You get to choose, basically, if you want to observe it. You don't personally, your city or your state officials and government and whatnot gets to decide that. But if you notice really, really closely, there's a blue dot inside of a green dot. So the blue shaded areas, I'm going to flip back and forth. This is daylight saving time. Folks that are observing daylight saving, switching back to non-daylight saving. Notice Arizona stays the same. Arizona stays blue. That's because they don't observe daylight saving, but there is green associated there. So that's actually the Navajo Nation, which there's a big Native American population in that area, and they chose, hey, we are not going to observe daylight saving. All right, and then within that blue dot, this little blue dot here, that's the Hopi Nation, and they do observe it. So it's pretty interesting. Just, within the politics, that's why a lot of the time zones are not precisely a beautiful line of longitude. So it's all about the politics and whatnot. Okay, let's go on with the entire globe. Who observes daylight saving? Because it's not only a United States type of thing. Although the majority of the U.S. and the majority of the northern hemisphere of the western hemisphere actually does observe it. So anyone shaded in red, they do observe daylight saving. Let's see, the purple shaded colors, they formerly observed it. So some parts of Canada don't observe it now, but they used to. Same thing for Arizona and parts of Mexico. They used to, they don't now. But you can notice everyone kind of has their own politics, whether they observe it or not. So that just makes it a little bit more complicated. Okay, last thing I want to talk about before we get into the forecasting aspect of why this is so important. I know it might be a little bit of a boring subject for some, but trust me, it's all going to make sense in just a second. So you want to learn how to read military time. You're probably used to looking at a clock, or if you're not used to looking at a clock like this, you're used to looking at a digital clock that says the exact time. My computer says 2:09. All right, so here we are, 2 o'clock. In military time is a 24-hour clock. So if it's midnight, it is at 0. If it's 1 a.m., it's 100. If it's 2 a.m., it's 200. Get the picture. We're at 11 a.m., it's 1100, but then it keeps going. If it's 1 p.m., it's 1300. So keep in mind, we went past the 12 o'clock hour, and then so at 1200, and then it keeps going. So 1300, 2 p.m. is 1400, 1500. So it's a little bit difficult, and it takes practice and some time to get used to. But the military time is a 24-hour clock, and it stops at 2400. Okay, and in order to talk to military time, they don't say when it's 1400 that it's 2 p.m. You mentioned that it's 1400. Okay, so done with these graphics. Now I'm going to transition to the internet, the computer, to talk about why this is so important, and hopefully it all kind of makes sense. Okay, so as a meteorologist, we all have our favorite website that we look at, computer models. So many different resources out there, pretty awesome. This is the one I use. This is my favorite one, Next Generation Weather Lab. So if you are interested, you can turn on the computer after this, or you can join me right now. Type in on Google, you can just Google Next Generation Weather Lab, or the website is weather.cod.edu. Okay, and it has so many fun meteorological things you can look at. So I'm going to click on Weather Analysis Tool, and then we're going to look at numerical models. So that's our computer models that we look at, that I look at daily. Okay, so what it's showing me right here is all the different models. Okay, we're going to do the GFS model. GFS model's one of the best models that we got here. All right, and then this website's pretty cool because I can focus in on different parts of the country or different parts of the world. I'm going to zoom into Texas. All right, so we're looking at the GFS model. We're looking at Texas. First things first, I want to show you this, 12Z. So Zulu time, it's actually the same as UTC time. So Zulu is still, the same system. So we're at noon. We're at noon in Greenwich, right? And what's our time zone here in Texas right now? Remember, we're observing daylight savings, so it's -5. So 12 minus -5, that's 7. 12, 11, 10, 9, 8, 7. So if it's 12 noon, then it's 7 a.m. This is a look at our model runs. The GFS model has 4 runs in a day. So that means it comes out with new data, new numerical forecast for us here. And we're taking a look at the most recent one, which occurred at 12Z. So the latest data that came out at 7 a.m. The next one's going to come out at 18Z. Okay, so our 12Z data. Okay, I know it's a lot. But again, you can rewatch this, and this is something kind of for the basics of forecasting. If you're someone who's been really interested in watching us on Weather School, and you really want to get into meteorology, this is stuff that you're getting a head start on. So pretty cool. Okay, so now we're looking at the timestamp. This is showing us the forecast, our 12Z model run, and now we're going to look at what's happening. Okay, so I'm going to stop right here because it looks like there's rain happening right over Houston. So every model has a timestamp. We're looking at Sunday. I know these are, ooh, man, I didn't mean to push that. Oh, great. Okay, yeah, we're back. I wish that would, okay, I'll just lower it here. So we're looking at Sunday. So this is showing rain on Sunday, 9Z. All right, so 9 Zulu, but we have to subtract 5 from that. So 9, 8, 7, 6, 5, 4. This is happening at 4 a.m. on Sunday. That's letting us know we're likely seeing rain at 4 a.m. on Sunday. All right, but with our forecast and the previous forecast that I've been watching, I know that this system is going to kind of start. Let's see. Let's go to Saturday. On Saturday, 21Z. So now we're heading in the afternoon, 21Z on Saturday. Let's subtract 5 hours, 21, 20, 19, 18, 17, 16. So 1600 military time. What time is 1600 military time? Remember, it's a 24-hour clock. I'm going to bring back our clock here. Keep that number in your head, 1600. All right, here's our clock, 1600. Let's look for that number, 4 p.m. All right, so 1600 military time, 4 p.m. That's the time that we're looking at. And now I'm going to go back to our computer model because I know what time we're looking at here. And so that means we're likely going to see rain 4 p.m. on Saturday. But you cannot only rely on one computer model. That's why you have several different models to look at. Also, the reason why it's important to look back at older model runs is because we like to compare what type of data was coming out earlier in the day or earlier in the week, and if it was pretty consistent that yesterday the 12Z model on Saturday was showing rain on the same time. Here we are, 18Z on Saturday, still showing rain. That's showing some consistency. So that helps us put together the fact that our forecast models are agreeing. But again, this is only the GFS model. So I would go to the HRRR model, which is our best short-term forecast model. Go to the same area. Anywho, you get the gist of it. So hopefully that kind of explained a little bit better the reason why understanding your coordinated universal time, and also just getting familiar with understanding military time in general, knowing what time zone you live in, and knowing if we are observing daylight saving at the time. That's the reason why it's pretty important as a meteorologist to forecast and put together some pretty, accurate forecasts for you guys. So I'm going to let you guys go, but I'm going to ask Randy. He's on the phone. Are you there, Randy?
I am.
All right, cool. So Randy's going to feed me some questions. Are there any questions? I know this class was, probably a lot to get through.
Yeah, not a ton, but Renee wants to know, why does Hawaii change if they don't participate in daylight savings? I don't know.
So Hawaii does not change. They do not observe daylight savings.
Okay.
So I know Hawaii and Arizona are the only states that do not observe daylight savings. So they always stay at -10, I believe. I'm going to go back to that graphic here. Yep. So see, this is our daylight saving graphic. Our number that we're at, Hawaii is at -10. So that's their number. And they stay at -10 when we're not in daylight saving. So their time will always stay the same.
Okay. The only other question I've got is from Colby, not on time zones, but just how you gauge your percentage of rain for a day.
Good question. So we take a look at, let's see. There's a few different factors, but it's based off of consistency of the models, like I described earlier. It also is based off of what type of model that you look at, because every model is higher in resolution or lower in resolution, and then just how much coverage we have in general with it. Sorry, this one is not loading very well. It takes some time to load. So there's several different factors that we look at, but I would say consistency, the coverage, every single model run, how consistent it's been, and then also how much moisture is in the atmosphere. Do we have a lifting mechanism? So there's kind of a lot of moving parts that goes into the pops that we put in, the percentage of precipitation.
Okay, and I think that's all the questions we have.
All right. Okay, so thanks for tuning in. I know this topic was a little bit different, but believe me, if you are interested in meteorology, this is something you're going to have to go through. Whether it's in high school, in college, when you barely start your meteorological education, a lot of the core is actually geography, and then you transition to a lot of math, a lot of physics, and then you go into the meteorology aspects. But it's going to help you out if you kind of dig a little deeper, do some Google searching, and just kind of practice. It really takes practice to look at computer models and kind of do the math in your head and find out what's going on. But I hope you guys have a happy Friday, and we'll be talking about the storm chances this weekend, coming up on the 411 in about an hour and 40 minutes. So we'll chat with you soon.